Hi everyone and welcome back to Maths and Physics from Mr. Simons. Today's lesson on electricity, we're looking at the second variation, and this variation comes from the KwaZulu-Natal paper of 2019 where they gave us voltage and they gave us power for a resistor. From there we must determine current and internal resistance. It's basic questions, right? So let's look at the question. They say the pattern in the circuit represented in the diagram below as the internal resistance R, so they haven't given us internal resistance. When switch S is closed, reading on voltmeter V2 is 18 volts, so there's S, that's 18 volts, and the resistor R dissipates 13,5 watt of power, right? 8.1, calculate the resistance of resistor R. So they gave me power and voltage. I'm going to use that 2 to get R. Calculate the reading on the ammeter A. Right, so from there I need to know how much current is used by R, how much current is used by 12. Those two added together should give me my ammeter reading. 8.3, explain in words what's meant by the term internal resistance. 8.4, calculate the potential difference across the 10 ohm resistor. So we want to know how much voltage is used there. Remember, if I have the reading of ammeter A, I automatically have current there, current and resistance together. I can then use to get potential difference. When switch S is opened, voltmeter V reads 45,9 volts. So if I open the switch, nothing in the circuit can use the voltage, so the reading should then be my EMF that they're giving there. Hence, calculate the internal resistance R. Then 8.6, does the internal resistance in the circuit increase, decrease, or remain the same when resistor R is removed? Alright, so first question, calculate the resistance of resistor R. So they've given me that voltage 2, hereby V2 is 18 volts, and R dissipates 13,5 watt of power. So I have voltage and I have resistance, so I can use the power formula on your formula sheet, power equal to V squared over R. Right? So P equal V squared over R, 1 mark for color selecting, correct formula, second mark for substituting, so in the place of V I'm going to substitute 18, place of power I'm going to substitute 13,5. Right, so you correctly put it in the right place, you get a second mark, and from there to solve, if I cross multiply, R goes there, this becomes 18 squared divided by 3,5. Right, and then that there gives me an answer then of 24 ohms. Right, so 3 marks, so R is 24 ohms, that is 12, and there's 10. That's the 3 resistors we have. Right, next question, 8.2, they say calculate the reading on the ammeter. Right, so we want the reading there by the ammeter, so I need to know how much current is used by the 12 and how much current is used by the R. So current equal, or V equal IR, so current equal V over R. No? Right, so VR equal I times R. So my voltage here by R is given as 18 volts. Right, and my resistance I had 24, so 18 divided by 24 should give me my current. Right, so they have 18 and I have a resistance of 24 there because that's what's given to me, 18 volts, and I have 24 ohm. 18 divided by 24, let's see, 6 goes in 18, 3, 6 goes there 4, 3 over 4 or 0,75 if I divide them. So 18 over 24, if I divide, should give me a current reading of 0,75 amperes, right? So there my current is 0,75 amperes, that is by R. Right? So that is what R is producing. Remember, in parallel, current is divided. So the current here plus the current there gives me the total current which is used in series, right? So we take a V, the voltage for the parallel, I have I12, and then times the resistance R, which is 12 ohms. Right, so I already have 0,75 for R. Right, that gives me I12, 18. Remember, in parallel, what stays constant? Voltage, right? So if R is using 18 volts, then 12 ohm is also using 18 volts. Right, so that becomes 18 divided by 12. Right, and that gives me an answer of 1,5 amperes. So now I have 1,5 amperes coming out to the 12 ohm, and I have 0,75. When the two meet and they move up to the 10 ohm, it's going to be 1,5 plus 0,75. That's my total current going to the 10 ohm, and that's the total current for the circuit. All right, so 1,5 plus 0,75, right, as you can see there, and that would give me 2,25. So there I have 2,25 amperes. So 1 mark for correct formula, 1 for substitution. There again, substituting, adding the 2 and getting the total current. So current in series, remember the 10 ohm is connected in series. Those two above each other are connected in parallel. So in series, current remains constant. So therefore the 10 ohm uses 2,25 ampere. And there A also has a reading of 2,25 amperes. Very important that you understand that. So in series, current is constant. In parallel, current is divided. Here in parallel, the voltage was constant, 18 volts and 18 volts, right? And that there we had to use then to get to how much current is used, right? Next problem. So explain in words what's meant by the term internal resistance. In short, internal resistance, I wish I could say it so nice like the French people, but in any case, internal resistance is the opposition to the flow of charge within a cell or battery, right? So when we oppose the flow of charge, we are resisting the charge. Therefore, if we resist it within the battery or within a cell, then it's internal resistance, right? Conflict within. Next question. Calculate the potential difference across the 10 ohm resistor. So there by the 10 ohm resistor, from these two, we got that the current is 2,25. So technically for 10 ohm, I have resistance and I have current. So from the equation R equal to V over I have two of the variables. So therefore I can find the third variable. Right, so I total equal 2,25 ampere, as I said. So there I have current and I have resistance, so therefore I can calculate voltage using V equal I times R. Alright, so V equal I times R, 1 mark for correct formula. I is 2,25 and R is 10. Right, so 2,25 times 10. Right, and that should give me, if I shift the comma, 22,5 volts. So there, 22,5 volts. So that is the voltage used here by the 10 ohm. Right, that's 22,5. These two are using 18. So all in all, there should be about at 40,5 volts external. Right, though they didn't ask for it, I'm just calculating it. So there, 1 mark for correct formula, 1 for correct substitution, and 1 mark for answer. Right. Now, 8.5, when switch S is open, V1 reads 45.9. So as I said, if I open that switch, nothing in the circuit is using the voltage. Therefore, that is my EMF. So EMF equal 45.9 volts. Hence, calculate internal resistance of the battery. So we want small r. So first I need to know what is my external resistance. Plus the small r, I have I, and therefore I can get then what the EMF, I can then get the value of a small r. Right, so using the EMF equation, let's see, I'm going to first work out what is my total voltage in parallel. Alright, so remember R there was 24 and that is 12, so I need to know in parallel what is my total resistance. So 1 over R parallel equal 1 over 12 plus 1 over 24. Right, to add two fractions, remember the denominators must be the same. So I can make 12 24 by saying 12 times 2 gives me 24. But what I do at the bottom, I must do on top. So 1 times 2 then becomes 2 over 24. Right, so 1 over R parallel equal 2 over 24 plus 1 over 24. Alright, now from there, denominators are the same, so I can add the numerators. It's going to become 2 plus 1 over 24. Right, and from there, if I flip it around, it will become then 24 over 2 plus 1. So 2 plus 1, 3 over 24. If I flip Rp over 1 would equal then 24 over 3. 24 divided by 3 gives me 8 ohm. Right, so these two here collectively, remember in parallel, resistance decreases the more resistors we connect. So as you can see, 12 and 24 connected in parallel gives me a total resistance of 8 ohm. So I have 8 ohm, and in series we simply add, so my resistance would be 8 plus 10. Right? Remember the current I got was 2,25 amperes, so that's the total current. Right? So if I use the EMF equation, I have EMF is 45,9. Alright, I have resistance now, the big R, which would be 10 plus 8. And then I have to look for the small r. Right? So here, EMF equal I times R plus R. So I said I have EMF, 45.9. I have I, which is 2,25. I can work out R by simply saying this 8 ohm for that 2 plus the 10 ohm, and then I'm just left with small r. So there, if I substitute, I have 45.9. Current was 2,25 amperes. R is 10 plus 8 plus small r. Alright, so this is going to become 45,9 divided by 2,25 equal 18 plus r. 45,9 divided by 2,25 equal 18 plus r. This answer here minus the 18 will then give me the value of small r, which in this case equal 2,40 ohm. Right, so that there is my internal resistance of r. So I hope you followed. I hope you enjoyed what I've explained. Wish you nothing but the best. God bless. Bye.